Hey, Dee Dee here in Walla Walla at the Monarch Super Fabulous 10EE lathe. Let's have a look into the switching compartment here. I like to have a look at things before I use the machine. I always check things out. So we'll open the door here and we'll have a look. Everything's all neat and tidy. I don't smell anything. If stuff starts burning on anything electrical, including that old guitar amp, you'll smell it. I just like to have a look over stuff, just, it looks real good. Everything looks fine in there. I checked out the main contactors. If you have any sign of trouble with the machine, check your contactors, okay? It's very important to get initial contact. The mains come in right here. Here's the disconnect switch. You flip this switch over and things begin to happen. We'll demonstrate that pretty soon. Okay, then we'll go over here to the this is called the electrical compartment. It's got the electrical switches. Over here under the headstock is the electronic compartment, and it has a tilt-out tube board here, and here's the vacuum tubes right there. Now, there's only 3 adjustments that you can make on this machine, and number 1 is your tube filament voltage for the big tubes. The filament voltage for the small tube comes from the back of the machine. But these 2 tubes here, it's critical that they have 2.5 volts AC. And depending on what voltage you're running on, you're going to have to juggle these wires to get that voltage. These are the filament voltage transformers. Now this little transformer down here below the small tube is not a filament transformer. That is your control voltage transformer, that or reference voltage. Okay, so that's the tube board. Here's your, these 2 tubes go to the armature. This small tube here powers the field in the drive spindle motor. These 2 coil here are the resistor, because the DC motor can become a generator, so they flip this across the armature, provide full voltage to the field, and the machine comes to a dynamic break in 2 seconds. It's a really amazing situation there. Okay, I'm going to put the tube board up about that far. Now here's a modification that I have made. I've taken and drilled the cover of the module, and that exposed the trim pots, potentiometers that are adjusted with a screwdriver. They don't have knobs like a radio. There's a lock nut there. Adjust the lock nut so there's friction, but don't lock it down. Now this one here is your top speed, and this one over here is speed compensation. Now these 2 things work from what my observation in tandem. Like if you adjust one, you're going to have to check out the other. And when you have these balanced out, when you crank the speed knob all the way up, it won't go faster than 4,000. If it's going faster than 4,000, then you need to turn it down. And you don't want it running faster than 4,000 or slower than 4,000. You want it to run at what it's supposed to run. And this here maintains speed under load. It's your speed compensation. And I'm going to fully demonstrate that and set that. You need to set these every now and then as the tubes and I believe the diodes start to decay a little bit. Then you're going to be adjusting these things. Okay, like I noticed if you change a tube or put new diodes in, you might have to readjust this a little bit. But once you got it set, it stays. It stays for a very long time. Now, one of the ways I've had great success with this vacuum tube drive is I know better than to overload it. And I've just had no problems in 22 years running this machine. And that's because I don't go over the speed compensation circuit to hold speed. If I see I'm doing that, see a tachometer drop, watch the tachometer. If the speed drops, then I back off. I just, there's no reason to overload this machine when I have other machines that are gladly overloaded. I had a Lodge & Shipley power turn, and that thing would move some metal, and now I got this little Axelson, and it moves metal. So if I need to move metal, I'll go to that. I'll go to a basic machine. I use this machine for just precision work, just for fitting bearings. Very important. Everything I've done is fitting bearings, and that's the reason for this machine. Also, it's got that quick switching over to the metric threads, and that was very good when I was in business. This machine was a very nice thing to have. So, okay, here's your electrical compartment. Everything looks good here. Here is the electronic compartment. Everything looks good here. So I'm going to get this thing warmed up, and we'll start running it and cut some threads and put the machine through the paces. I know there's a few guys out there that just got these machines. You're a little bit uncomfortable with them, and hopefully I can show you a few things, make things go a little bit easier. But keep in mind, it takes a little while to get used to a machine. I'm very used to this machine after 20 years. I don't have to look for anything on it. But I'm still on the learning curve with the monster Axelson. And its shifting is building up my arms like Popeye. But this, using a Monarch 10EE, you are on easy street. Okay, I'm going to go topside here and we'll have a look at some things. All right, now I got this machine here to make parts out of PreHard steels. That saved me tremendous time over the years. Rather than carving something out on the lathe, sending a piece of steel to an induction hardening service, which I do. I don't like to have that kind of facility. I'd rather have stuff induction hardened if there's specifications. But most of the time, or a lot of the time, I can make parts out of PreHard steel. This Monarch 10EE works it better than anything I've ever used. It just holds outstanding accuracy. So that's the reason for this. Otherwise, I would be having to have parts hardened and grind them. Okay, so this thing can save some bucks, but there's times where you have to use the old processes like that. So in order to get that material to work, and a lot of people have found out with hardages, other precision machines and stuff like that, you're going to get the best accuracy out of a small diameter 4-jaw chuck, as small as possible. And you can do really good work on these kinds of things and stuff like that, but when it comes right down to it, this is the one that you're going to get the highest accuracy. This is the one you're going to have to use to get close to the Kennametal Ramacron boring head systems. Guarantee a plus or minus 80 millionths of an inch. And that's as good as you're ever going to get with forming chips. And you're going to have to meet a lot of criteria to do that, and you're going to have to work at it. But my goal is just to fit bearings. That's it. And if you have a bearing failure, man, that's a bummer. It can just cost thousands. So that's the reason for this stuff, that I do that. And there's other ways to do things, But this thing is an incredible time saver. Plus that metric threading, you know, it's pretty nice. Now, I had a Monarch 10EE and I had to use the change gears on it, and it took a full hour to, even more, to change that out. To change those change gears, you got to take the cover off that box. You got to mess with that stuff. It's all tight in there and all that stuff. This, it's a horrible thing. And I had the same problem with the Watch and Shipley lathe. I had to change gears for it. It had pick-off gears. It was easier to access it and stuff like that, but it still took an hour. And actually, the lathe that old style lathe that's great for cutting metric threads is the axle set. The idler gear is 127 tooth. Okay, so this is it, and I will be back. I'm gonna fire this thing up. We'll get it warmed up. We'll check the top speed, and I'll show you how to set the speed compensation. Okay, I'll be back with that in a while. I've been using these machines for over 3 decades. When I bought this machine 22 years ago, people didn't know what they were. And machine tool dealers didn't like them because the machine tool dealers belong to an organization and they have returns and things like that. And one of them that's important, at least to one machine tool dealer I know, and I was talking to a fellow about it, but I didn't give him quite the backstory, is you buy a used machine from a dealer, it belongs to that, whatever. You're going to get a machine that's not going to electrocute you and will start when you push the button. That's really important, you know, that everything's grounded, electrical stuff, because you can get electrocuted by these things. And I'm going to tell you, at 22 years of having this machine, it has not failed. And that's because I know how to use it. And you get onto some of these web forums and stuff like that, and that's where stupid begins. Like that one web forum with the Monarch section and stuff like that. It's got that troll termite and its butt cheek drive. What is that? A double urethane Parker with a ripple filter right up my cavity. That's totally stupid. I just think it's ridiculous. But there's people that praise it. Oh, it sounds so good. You know, I don't, you know, actually I'm a professional user of the machine, and I find amateur users absolutely irritating. But I do the best I can. But there's some parameters that you got to think about yourself. And I've run this machine here for 22 years without a problem, but I guarantee you, in one day, a person could really cause severe damage to this machine. In one day, or just, you know, maybe an hour, could really hurt the machine. So it's like in the manual, the Monarch 10EE manual, it's not like how to run the South Bend or Atlas lathe manual. They just barely point out the controls. You are expected to already know what you're doing when you operate this machine. It's just the way it is. This thing costs as much as a house. So it's not the Atlas lathe that you should start on. But people do buy these as their first machine. I'll do the best I can to help you, but don't come to me for Mickey Mouse drives, because I'm not going to go there. The only drive that seems satisfactory for the home user, if I can remember, is a VFD, I guess 5 horsepower. I think when you get over that, it starts requiring 3-phase. The best 5 horsepower VFD you can buy with the brakes, with that and speed or whatever it's got, and they graft this 2-speed gearbox. This is your back here, right here, and they graft this thing onto an inverter duty 5-horse motor. I think they call it a Black Max or something. It's one of the brands. But that's a lot of work, you know. You are not going to successfully power this machine with those little goofy boxes and a ripple filter. It's not going to happen. It does not work. So this is the hard bullet to bite. If you can't go with the original drive, you're going to have to go to an inverter, you know. And if you can't afford what the factory's putting out, you're going to have to go with whatever. But don't try to run these DC motors on those little plastic boxes. It's ridiculous. It don't work. I've seen it. I don't know. But I'm going to demonstrate this machine and show you how it's supposed to function. And I think that's important for people that have them, because I talk to people and they tell me how the machine's running and they're not running right. So I'll show you how one runs right, then figure out how to get there. Okay, so this is the back end of the lathe here, and I'm going to tell you something. I adjust these belts running, with the machine running, these V-belts here. I use this right here, I loosen that, and I run it at full speed, and I move this in and out, being very careful not to get tangled up in the works here, okay? You know? So I adjust the belt so it runs the smoothest, these two V-belts here. And that makes them pretty loose, see? They're fairly loose. It's kind of like on the woodworking equipment. Adjust it so it runs the smoothest. You know, like a table saw, if the belt's too tight, the metal cabinet rattles, you know? You just got to be aware of what's going on here if you want to get the best results. Look at this motor tag here. I want to show you something. I'll get it real close so you can see it. Look at this. It says right down here, balanced 2 3/10,000ths. I'll tell you, it's just a smooth running motor. This one here is a Lewis Alice, I believe, on this one. Lewis Alice Flexitorque. And I was told by a fellow that this motor cost over $10,000 for a replacement. So that's something to think about, what went into this machine. You know, if you're going to put a bunch of crap into it, you're going to get crap out of it, all right? Now I'm going to show you something else. Look at this. I don't know if you can see it real well, but that belt has left rubber down in there. Same up here. So I frequently clean those grooves out so there's not that rubber. And I also use alcohol on the belt to treat it. Yeah. Now the belts I'm using here are Goodyear Matchmaker, and they're the notch type. Some people don't like them, but I use them because I run this machine fast and the belts do get hot. Okay, so I got this thing tuned, and one of the things that I found is that adjusting these belts so the machine runs the smoothest at the highest speed, they squeal if I got a chuck on it and try to start the machine at top speed. So, and this is a good safety thing. Anyway, how are we doing on time? I'm going to load this video and keep going. We're going to have to do it in sections. There's a lot to go through. On the speed knob, I got a dab of paint here. I want you to notice the speed knob here has no numbers, nothing. So without that paint, you don't know where it is, okay? And if it's all the way over and you turn that thing on, it'll go to 4,000 RPMs in 2 seconds. And if you have something loose in the chuck, it's flying out. I've done that a few times. So what I do, if I'm running the machine at top speed, I'll stop the machine. Let the dynamic brake bring it to a stop, but before I restart, I just reach over and do that. Start it there, ramp it up. It's smoother and easier on the machine, okay? And it helps with that stick-slip thing that I've talked about, where the shock of the machine all of a sudden sends the cross slide forward from the built-up tension of the oil and the pressure of the screw. Okay, I'm going to load this and I'll be back with another video.